All right, I want to look at a couple of examples of how we use the mean value theorem. The first one is more concrete example, the other one is more theoretical, sort of a proof kind of thing. So here we go. The first one, um, find the point on the interval from -2 to 3 that is given in the conclusion of the mean value theorem, with the function being x squared. Okay, so notice f of -2 is equal to -2 squared, which is 4, and f of 3 is 3 squared, which is 9. Okay. Also, I noticed that f prime of x is equal to 2x. So, what's the mean value theorem? First of all, this is a continuous function, right? It's polynomial, it's differentiable. We just took its derivative. Um, the mean value theorem is saying that somewhere that the derivative 2x is equal to the average slope, and the average slope is the f of the 3 is playing the role of b, right, and the -2 is playing the role of a. So this is f of 3 minus f of -2 all over 3 minus -2. So I'm saying somewhere 2x is equal to 9 minus 4 over 5, which is 5 over 5, which happens to be 1. So where is the slope ever equal to 1? The average slope is 1. Where is the actual slope equal to 1? Well, this is the actual slope for any value of x. Just solve for x. X is equal to 1/2. Just happened there. Is equal to 1/2. There we go. So although the mean value theorem didn't tell us where it was going to happen, it just told us that it would happen. In fact, 1/2 is somewhere between -2 and 3. And so we've got our particular value of x. It doesn't tell you where, but it gives you the equation to solve that. Once you solve it, you know where it happens now. Okay. All right, so there's my more concrete example. You'll find several of these in the homework, these types of questions. And next I want to do one. This is a question that came out of a textbook a bunch of years ago that we used to use. And it stated like this. It says a marathon runner runs a marathon, which is 26.2 miles, in 2.2 hours. This is actually a pretty good marathon runner. The book that I got this problem from asked the question, show that the runner ran exactly 11 miles per hour at least twice. And I couldn't do it. So I use this now as an example of what actually can we conclude from this situation, right? So and then what more assumptions do we need to get that the runner actually went 11 miles per hour or went 11 miles per hour twice? So what I see here is I see that the average speed is 26.2 miles divided by 2.2 hours. And 26.2 divided by 2.2 is 11.9090909, etc. Okay, it keeps repeating 90909. So what can we conclude here? Well, first of all, we've got to make the argument that the position function is continuous. That is, the marathon runner doesn't teleport from one spot to another. They have to pass through from the start line to the finish line. They have to pass through every point in between somewhere. They don't just teleport over. So position is continuous. Also, I have to argue that the velocity is always defined. And well, and more so that the velocity is continuous. That the runner doesn't just just suddenly, running along at this speed and then just suddenly be running along at a faster speed. It doesn't just instantaneously change speed. In order to do that, it would take actually an infinite amount of energy because you're changing the momentum. instantaneously, and it just takes a tremendous amount of acceleration to make that happen. So when the runner speeds up or slows down, it does it maybe quickly, but still not instantaneously, and there'll be a smooth curve at every point there when we're looking at the position function. Okay, so the position function is continuous, it's differentiable, it satisfies the conditions of the mean value theorem. Okay, so what the mean value theorem says, so by the mean value theorem, there is a place where we go exactly the average speed, where the actual speed is 11.909 miles per hour. Okay. Now, maybe the runner was running the whole time at 11.909 miles per hour, and so it wasn't ever running 11 miles per hour. So, although the book asked me to say 11, I can't. So it's like, all right, what do I need to assume? Well, you say, well, wait a minute. They didn't start off running, if this were a bike race or, a car race where they're actually already moving, when they're on bikes on a track or cars on a track, they're quite often already going, and when they cross that start line, they're already moving at some fast speed. Right? But in a running race, generally, the runner, particularly a runner that's going this fast, probably gets a starting position up on the front line and is already it's not already running, is actually stopped. So they're standing there at the starting line waiting to run, right? They're all ready to go. Starting line's right here. But their velocity is 0 at that point. So again, the velocity is a continuous thing. If it goes from velocity 0 at the start up to velocity 11.9 at some point, then it must have passed through 11 at some point. So this runner, if we're in the assumption that it started off from a standstill, so velocity 0 going up to velocity 9, then that has to somewhere hit 11. And that's what we use. That's called the intermediate value theorem. Intermediate value theorem, right? That was from early on in the quarter, the property of continuous functions. If you go from 0 up to 11.9, you must have passed through 11 somewhere, provided, of course, it's continuous. The book says twice. It's like, twice? I get once out of you, but twice? Well, so it's like, well, what are they thinking? What are they thinking to get twice? Well, what they're thinking is that at some point, you got to slow down again, right? But personally, when I think about a marathon runner that can run 26.2 miles in 2.2 hours, this is like world-class marathon. They don't come in to the finish line. Here's the finish line. The runner doesn't come zooming in and stop. No, they just run right through, right off the other side, and they're still running. Heck, maybe this is Forrest Gump and is still running today, right? Maybe that's never slowed down. So in order to get twice, I would have to argue that at some point after the 11.9 was reached, that the runner came back down to 0, let's say, or at least below 11, and then did it. So the mean value theorem guarantees somewhere we did 11.9 miles an hour. Under other assumptions, we might be able to argue something else, something less than 11.9. I certainly can't argue more than 11.9, because it might have been running, the runner might have been running 11.9 miles per hour the whole time. So I can't argue more. If I assume you started from a stopped position, then we can argue the 11, but that's about it. Okay. Anyway, the mean value theorem. I don't know when they were 11.9. I just know at some point, since the average was 11.9, they must have been running for at least one instant at 11.909 miles per hour.